In this problem, we want to determine whether each function is even, odd, or neither. So let's go graph it. I'll press my y equals, press clear. I got x squared, so I do x key, the x squared, plus the absolute value of x. So I'll do math, right arrow to num, enter on ABS, put my x key in, closing parentheses if you want, but you don't have to have it at the very end, and then I'll press graph. And I can see it's an even function, because if I take the right side of my graph here, if I flip it, reflect it across the y-axis, it would land exactly on this part of the graph. That means it's even. It's symmetric to the y-axis. Okay, now if you're curious how to do it by hand, you don't have to for the homework. I'm happy with the graph approach. We've got y is equal to x squared plus absolute value of x. To decide if it's even or not, what you do is you plug negative x in for x and see if you can get it to look like your original function. So we got negative x squared plus the absolute value of negative x. Well, negative x times negative x gives us a positive x squared, and when you got the absolute value, that makes whatever's inside positive. So that becomes plus, well, actually we show it another way. When you got negative x, that's same as like negative 1 times x. And I think this will better demonstrate it. And so then we can split this up into the absolute value of negative 1 times the absolute value of x. And absolute value of negative 1 is 1. So then that basically just becomes the absolute value of x. Basically, if you have a negative in front of your absolute value, or a negative inside the absolute value, you can just drop it, just like I did there. Now you see this equals our original function. Since it does, that means it's even. And if it's even, I don't have to go through and check if it's odd for a function.